Hello, this is a video to tie into an up and away project with dealing with hot air balloons. And this is just a video on volume of cylinders, cones, and irregular objects, which could help you find the volume of your hot air balloon. So if you've got a CTE class that has hot air balloons that you're doing a project of, you can use the information that you see in this and this lesson, and hopefully it'll apply to your hot air balloon project. So let's start with a jelly beans. Now I have a bag of jelly beans in my hand. If I'm in front of the class right now, or if your teacher's in front of the class and they have a bag of jelly beans, you need to take a guess at it and look at it and make a guess. Put your guess on the line that you see here, and put a guess on another piece of paper that the teacher will collect. Whoever gets closest to the right guess gets to keep the bag, but we won't find that out until tomorrow or the next day, depending on how many days it takes us to get through the lesson. But I think at the end of the lesson, you'll find a nice way to maybe figure out a good way to estimate how many jelly beans could be in that bag. All right, let's move to the notes. Volumes of cylinders and cones. Volume of a cylinder. There's a little website here that I wanted you to look at. So it's a really good website. It's a learner website, interactive. It's got some things on it, and it's talking about the volume of a cylinder. And then trying to fill a cylinder with unit cubes is pretty hard, because when we measure volume, we always measure it in cubes. But you can tell that cubes aren't going to fit into a cylinder very well, because the cylinder is round and cubes are, little squares. So you have to just focus on what they say is you have to fill the cylinder. You have to focus on the process for finding the volume. So the process for finding the volume of any prism or cylinder is to first find the area of the base. Now in this case, the base is a circle. In every cylinder, the base is a circle. That represents one layer of cubes, and then you can multiply it by the height, which would be how many layers of cubes that you'd have. So in this case, it says, what is the area of the circular base of the cylinder? Remember from the section on surface area that the area of the circle is A equals pi r squared, where r is the radius of the circle and pi is 3.14. So we're looking for the area of the circular base. So let's grab our calculator. And it's going to be a radius of 2, so it's going to be pi times 2 squared. 2 squared is 4, so pi times 4. You're going to get 12.56 for your area. Okay, good job. And then they tell you to move on. Now, what is the area of the circular base? Okay, what is the height of the cylinder? So we found the area is 12.56. The height is right here. It's a 6. And none of this you have to write in your paper. I just want you to take a look at it. Okay, so we got 6. Again, great job. We did it right again. And then it says, what is the volume of the cylinder? We now know the area of the base is 12.56, and we know the height of the cylinder is 6. So you multiply those two together. So again, let's grab our calculator. 12.56 times 6, and it's going to be 75.36. So 75.36. And you hit it, and you got a good job. Now you could practice with as many as you want. You could restart it. You could find the volume of another cylinder and just practice and do as many as you want. The website is right on your notes right here, so you can go straight to that website and practice with volume. So here's our formula. The volume of a cylinder with a base area B and a height h and the radius r, which we know all those letters is from our formula. B is volume, big B is the area of the base area, and h is our height. And our volume is just area of the base times the height. And in a cylinder, you can take out the b and you can put in pi r squared, because the b is always going to represent a circle in a cylinder. So take out the b, put in pi r squared h, and you'll have the volume of a cylinder. So if I'm looking at this cylinder right here, it's got a radius of 2 and a height of 4. Your volume is going to be pi r squared h. So it's going to be 3.14, which is my pi. And again, if you have a pi button on your calculator, I would use that. It'll be a more accurate answer. Radius squared will be 2 squared, and then your height is 4, and you multiply all that together, you get approximately 50.24 cubic meters. So that is our formula. We have pi, we have the radius squared, and we have the height. Now let's take a look at a pizza, because volume can really be as easy as pizza. If you can remember pizza, you can remember how to find the volume of a cylinder. Let's say we've got a pizza here and the radius is z. Okay, so from the center to the edge, we're going to call that letter z. The thickness of the pizza is a. So if we follow our formula up here, we have pi times the radius squared times the height. In my formula here, pi is 3.14, so I got pi. My radius is z, and I need the radius squared. I need 2 squared, or I need z squared. Z squared means z times z is what that means. And then my height, my thickness is a, and you're going to multiply by the height. And really, you just remember the word pizza, and you'll know how to find the volume. So it's as easy as pizza. And that came from a website right down here, mathisfun.com. If you click on the website, you can see all kinds of cool stuff about cylinders. Gives you the surface areas and the volumes. Talks about the pizza, thickness A, the Z, and the PIZZA. So you can go through that if you want to. I put the website on there for you. Alright, and you can, again, pause the video anytime you need to if you need to stop it and let them catch up. Alright, let's find the volume of a few cylinders. I got my radius of 6, I got my height of 8. So I'm going to find the volume of this cylinder. I'm going to do my 6 squared times pi times 8. Multiply that together, and you get your volume. And again, most of this is filling in the formula and using a calculator. But what if they gave us volume? Now this is a cube. I know we're not talking about cubes in this section, but for a cube, we have a formula that says volume equals the side cubed, because it's length times width times height. So just to show you, we could use volume, and to use volume to get the x, we would have to do the third root on both sides. You would take your third root. I'm trying to write with a mouse, so that's why it looks a little weird. You took your third root on both sides. The third root of 100 would be 4.64, meaning that 4.64 times 4.64 times 4.64 is going to give you really close to 100. So that would be your cube. Now, what if they gave us the volume of this and we got a height of 12, but we don't know the radius? Could we find the radius? Well, we would first plug in our formula. 4,561 would be my v equals pi times radius squared times h, but this time I don't know the radius. So I would want to divide both sides by 12 pi, and my radius, then I would have to square root both sides, and my radius will come out as 11. So you would simply divide both sides by 12 pi. Divide both sides by 12 pi. And then you should put the 12 pi in parentheses. Sorry, writing with a mouse is really hard. And then you would square root both sides, you get 11. Because when you divide this by 12 pi, you're going to get about 121. And the square root of 121 is really close to 11. So that would be your volume of this. That would be finding the radius if they gave you volume. Okay, let's talk about cones. We talked about cylinders. Now a cone is very similar to a cylinder in the sense that it has the same kind of circular base. It's always going to have a circle. But a cone only has one base. It doesn't have two. The cylinder has a top and a bottom base. The cone has a slant height because it's got a diagonal height coming up to the point up here at the top, where is our vertex. It also has a regular height, h. This is a dotted line right here because you can't see it. It's actually inside the cone going straight down, like if I took the top off the cone and I dropped a tape measure straight down. That would be my height. It's right to the middle of the base. And then it's got a lateral surface, which is the sides of the cone itself, the lateral surface. And then it's got a radius. The center to the edge would be the radius. So how does the volume of a cone compare to that of a cylinder with the same base radius and the same height? Because we saw the cylinder, we took the area of the base and just times it by the height. That's what we were doing back over here. We did the area of the base, pi r squared, times the height. So now we have a cone which still has a circular base, but it's not filled in all the way. So how does that relate? Well, here's a little video clip that will help you see how a cone and a cylinder relate to each other. It's really short. Here's your cone. Here's your cylinder. You can tell it's a cylinder because it's got the circular base. They're going to take the cone out and they're going to fill it with water. Fill that cone with water and you dump it in, and it fills it not even quite halfway. Then you fill it up again, and it fills it a little bit more to the top, and then you fill it one more time, and it fills it up completely. So what does that tell me about the way that a cone and a cylinder relate to each other? Because it looks like it took 3 of these cones to fill up one cylinder that has the same circular base and the same height. So we would put something like the volume of a cone is 1/3 the volume of a cylinder. 3 cones were able to fill up the cylinder. If you dumped 3 cones into the same base size with the same height cylinder, it would take 3 of them. So again, you can pause the video if you need to. I'm a little quick. Okay, now formula for volume of a cone. We just learned out that it's 3 cones makes 1 cylinder. So here's my formula. It's 1/3 of the area of the base times the height, or 1/3 pi r squared, because that's my big B. You can always take out big B and put in the pi r squared with a cone or a cylinder, because they have a circular base, times the h, the height. And I would actually write it more like this. B times area of the base times the height divided by 3. So instead of having the fraction, I just divide it by 3. Don't forget, big B is not a base, it's the area of the base. Little b represents a base. Big B represents the area of the base. And h is always the height at a right angle. And it's always an inside height. So let's find the volume of a cone with a base radius of 5 and a height of 4. So what we would do first is plug in our formula. You've got your pi r squared times h, pi times radius squared times height, divide by 3. That's my formula. You put all this in your calculator. You put the top part in your calculator, you divide it by 3, and you get your volume of 104.72 cubic inches. So if I didn't divide by 3, if I just did this top part, it would give me the cylinder. When I divide by 3, it gives me the cone. It gives me the cone shape. So that's how you find the volume of a cone. Okay, moving on to a couple of other examples. Again, we've got a radius and we've got a height. So you're going to plug in your formula, pi times radius squared times height, and then that would be the cylinder. That would be the volume of my cylinder, then I divide it by 3 to get the cone. And that's going to give you 440.57 cubic inches for volume of a cone. Again, you can pause it to slow it down if you need to. Now, a cone-shaped paper has a height of 5 inches, so it's got a 5-inch height. The cone must hold 50 cubic inches of water, so the volume has to be 50. What radius should we make the base of the cone? So what we need to do is fill in the pieces that we know. We know 50 is my volume. We know pi r squared is my area formula, but I don't know r, so I have to leave r in my problem. And then I know my 5 is my height, and I divide by 3. The first thing you're going to want to do here is multiply both sides by 3. That is going to be the first thing you'd want to do. Multiply both sides by 3. So I'll put little dots here so you can tell that's multiplication. Multiplying by 3, that cross cancels out your fraction. So now what would basically happen is these 3's would cross out. And over here you'd have 150. So you'd have 150. You'd have 150 equals pi times r squared times 5. So you'd have your pi r squared times 5. Okay, let me put a pi there so you can see the pi. Okay, so pi times r squared times 5. Then you would divide both sides by the 5 pi again, just like we did before, to get r squared. So you divide both sides by the 5 pi. And you would want to put the 5 pi in parentheses. Just helping them out just in case they are not sure on the steps here. And you would definitely want to put both of these in parentheses, otherwise it won't divide it by the whole thing. And then you're going to get r squared, and then you're going to square root both sides. You'll end up with that r is about 3.09 or 3.1, and that would be inches. So 3.09 inches. Here's a little critical thinking. If you're given the radius, like this 6.3 right here is the radius. So let's say they gave you this radius, but they also gave you the slant height. Let's say that this 10.6 was actually the slant height right here and not this inside height. Then what would we need to do to find the volume of the cone? How would we find this volume if we had the radius and the slant height? You can pause the video and discuss it. But I'm going to reveal the answer, and here it would be. You would use the Pythagorean theorem to find the height. Once you know the height, then you can plug it into the formula and find your volume. But you're going to need that extra step of doing your a squared plus your b squared equals your c squared. And remember, the slant height will be your c squared because that's your hypotenuse of this right triangle to get the h. And then once you have h, you can plug it in and find your volume. Okay, volume of irregular objects. These are objects that are not, shapes that we would know. There's two methods. One, there is a water displacement method. So you can see how much water would move. Is basically what would happen here. Is the height difference can be used to calculate the volume change, and so the volume of an irregular object. Let's say you wanted to find out the volume of a rock. So you have a cylinder, you measure the volume of the cylinder, or how much water is in there, so you find the area of the base, times it by the height, and then you drop the rock in. You put the rock in, the water goes up. So you measure the difference between those two, and that's going to be your volume of the irregular object. So the same thing here. If it was at 50 milliliters, and you dropped in a rock and it went up to 75 milliliters, then your volume is 25 milliliters for that object. But there's another way to find the volume of an irregular object, such as like a Ziploc bag, a paper, or any kind of trash bag or paper bag or anything like that. Is you could simply, if water displacement is not an object, you fill the bag completely as full as you can get, and then pour the contents into a cylinder. Find the volume of the cylinder to the height that the contents went up to on the cylinder. So you would fill up your Ziploc bag with water or powder or rice, whatever, and then you pour it into a cylinder, and then you measure the volume that would be in that cylinder. Now let's say your bag is more in water than the cylinder. Well, you can just see how many cylinders it would fill up and measure that volume, and keep pouring more bags in until you get the finished end of your Ziploc bag, and then you can measure that cylinder. So that is how you would find the volume of an irregular object, and that is exactly what you're going to be working on. So as a class, you're going to be coming up and measuring the volume of a sandwich bag, a medium bag, a large freezer bag. These numbers are all rounded to the nearest. You can round them to the nearest whole number. You can find the surface area of that bag simply by finding the area of one side and doubling it. You can find the volume of that bag, and we're going to see how they relate to each other. How surface area relates to volume. And so you could see that when you're doing your hot air balloon project, your surface area, how it might relate to your volume of your hot air, so you know how much to put in or how big of a bag to use. So that's going to be what you're going to start with. You're going to find and you could even do the snack size bag if you have them. And then you're going to graph that information. and find out what kind of graph it is. This is all going to be, your assignment here, your little project. And then you can find the volume of some grocery in trash bags just by using the dimensions and the surface area and the volume. Using our chart here and finding an equation, you could use all that information. You don't even have to measure the contents of the grocery and trash bags. If you know an equation, you can figure that out. So that's your next part. And then of course your conclusion would be, we're going to find the volume of a jelly bean. And you're going to follow these steps with your teacher, find the volume of the jelly bean, or at least one jelly bean, and then make an estimate. You could probably make a pretty good estimate as to how many would be in that bag, and you might want to change your guess, but I don't think they're going to let you change your guess at this point. All right, and that is it. So good luck. I hope you do well on the rest of the assignment.